We have 3 times root 6 times 4 times 2 times root 6. Well, what's the smartest way to multiply these? Why don't I multiply all the numbers first? Because we can multiply in any order. 3 times 4 times 2, well, 3 times 4, that's 12, times 2 is 24, so we have 24. And then what's root 6 times root 6? This is very important, right? Anytime you multiply a square root times another square root, you're going to get the number under the root, so it's just going to be times 6. If you want to go ahead and write out root 6 times 6, which is square root of 36, which is 6, that's fine, but notice you still get the same 6. And then you have 24 times 6. Well, that's doable, right? That's just what? 120, 24, 144. And that's your answer, 144. So break it down, all the same, right? Put it together, and hopefully you get a nice and neat answer like that. Now your calculator can actually do this stuff, so if you really get stuck, double check with the calculator. Even if you don't get stuck, double check with the calculator, right? It's a nice tool. Same deal here. Break up these roots. Put as much as you can out of the root, combine stuff together. But in this case, right, looking at these numbers, it's easier to just go ahead and multiply these roots. This is like the same thing, root a times root b. Just go ahead and put them together under the root, a times b together. So I'm going to put these numbers together, right? So 15 and 5, y to the 6, y cubed. So 15 times 5, that's 75. So 75, and what's y to the 6 times y cubed? We know if we multiply with the same base, we add the exponent, so we get y to the 9th. Okay, so we got our y to the 9th, and then, okay, well, business as usual. What's the square root of 75? Well, that's 25 times 3. So I'm going to break it up into the square root of 25 times the square root of 3. And now this is the other thing, right? How many times does 2 go into 9? 4 times. I'm going to bring a y to the 4th out with a remainder of 1. And now, right, the square root of 25, well, that's just 5. So you have 5 root 3 y to the 4th square root of y. And what do we say? Put those roots together and stick them on the end. So we have 5 y to the 4th, and who's at the end? Square root of 3 y, right? Just put those roots together at the end. And this is your answer. So hopefully that's clear, and we're going to go ahead and move on with that. Again though, right, you can always pause, replay, rewind, take it at your own pace. Just make sure you get these concepts because they're not going to go away. Okay, so let's move on. Okay, more of the simplifying stuff, right? Go ahead and combine these roots together. Right, again, 4th root of 4, 4th root of 20. 4 times 20 is 80, so we have the 4th root of 80. And try to ask yourself which perfect fourths go into that, and then you'll see that, okay, well, 80 is just 16 times 5. So we'll have the 4th root of 16 times the 4th root of 5. And the 4th root of 16 is a nice number. It's 2, so you have 2 4th root of 5. And that's your answer. Right? Nice and simple. Find a perfect fourth, right, that can come into 80 and then break it up. You've been doing the same thing for all of these roots. Okay, so let's keep going. Okay, we talked about this a little bit. This is just distributive property. We're going to take this whole thing and multiply it here, multiply it here. It's no different than if you have something like 2 times x plus 3, right? You just multiply the 2 times x and the 2 times 3, and you would get 2x plus 2 times 3. Well, that's 6. And that's your answer. We're going to do the same exact thing. We're going to distribute this thing in the front. So we're going to have what? 2 root 6 times root 2. Well, that's 2 root 6 root 2. Minus what? 2 root 6 root 7. Well, let's write that. 2 root 6 root 7. Now what can we do with these roots? We can combine them, right? Using that property we keep talking about. Go ahead and multiply them together. So we have 2 root 12 minus what? 2 root 6 times 7? Root 42. Any perfect squares in 12? Yeah, 4 times 3. So we have 2 root 4 root 3 minus any perfect squares in 42? let's see, 4, 9, nope. 16, nope. 25, no. 6. So 42, I don't know if that's friendly, right? 42 is just 2 times 21, and 21 is just 2 times 3 times 7, so no matches. That can't be broken up. Just gotta leave it as root 42, and that's fine. We just keep going with it. And what do we have? Well, 2 times root 4. Well, root 4 is 2, so we have 2 times 2, which is what? 4. Then we have root 3 minus 2, root 42. And it says simplify as much as possible. Well, that's about as simple as we're going to get that, and that's fine. So, okay. Yeah, because 42 divided by 3, what is that? Nope, 14 is not a perfect square, so we just got to leave it alone. So good. So don't get paranoid when you don't see perfect square at the end. Maybe double check your work once or twice, but other than that, it is what it is. So don't, you don't have to feel, worried about that. Right now we're on page 102. You'll notice the number is the same as what's right there. Same deal. Distribute that root 6. Root 6 times root 6. Well, we talked about that. That's just going to be 6. And root 6 times 6 root 7. Well, it's going to be what? 6 root 7, and you're going to have that root 6 as well. So you're going to get 6 plus 6 root 42. And as we just learned, root 42 is what it is, so we got to leave that guy alone. And this is our final answer, because root 42, you can't break that up into any perfect squares. You're done. Okay, let's move on. So what about when we have something like this? Well, this looks a lot like FOIL, right? We have something minus something times something minus something. We're just going to do our first, outer, inner, last. That's it. So let's go ahead and do that. What do we have? We have 5 root 2. We have a negative 1, a positive 4, and a negative 3 root 6. So let's do our first. 5 root 2 times 4. Well, 5 times 4 is 20, so we have 20 root 2, right? Combine our like terms. What about our outer? 5 root 2 times negative 3 root 6. Don't forget that negative. So what are we going to get? Well, we're definitely going to get a negative. 3 times 5 is 15. And root 2 times root 6 is root 12. Okay, good. Broke that up, right? So now we have our first, our outer. All right, we're doing FOIL. F-O. Now we need our inner, our I. So that's just negative 1 times 4. That's negative 4. Good. And then we need our last, right? Which is what? Negative 1 times negative 3 root 6. Well, negative and negative is going to be a positive. And then, well, it's just times 1, so we're just going to get 3 root 6. Now we need to combine everything as much as possible. Are there any roots that we can simplify? Well, root 12, isn't that just root 4 times 3? Yeah. And root 4 is a perfect square, so go ahead and break that up. We still have our 20 root 2 minus 15 root 4 root 3. That's our root 12, right? Minus 4 plus 3 root 6. Well, let's take out that root 4 and turn it into a 2. So we have 20 root 2 minus 15 times 2. That's 30 root 3 minus 4 plus 3 root 6. Do we have any common roots that we can combine? No, we don't. So guess what? This is our answer. Plain and simple. So break it down. You can do it. You can bring these guys together and you can take care of it. This is just FOIL. It looks like FOIL, right? Something times something all together times something times something. When you see the parentheses like that, you should immediately think it's going to behave like FOIL. And sure enough, it does. Okay, let's move on. This is about where we left off for the quiz.